So I'll just continue with from where I left off in session one. In session one, we were discussing about the data sharing platform that we are developing at UCSD in collaboration with our partners. Here, we'll be talking about, like actually, Onur had mentioned some statistics. I was not aware of the statistics. All we are seeing in the real world is that the amount of data that needs to be transmitted back and forth is just humongous. Well, as Onur said, and as you can understand that in this data sharing platform, for instance, the vehicles, they can either transmit raw data, raw video, raw radar data, or they can all be encrypted, even point clouds extracted and just sent, right? But each of those have different trade-offs, different implications on security, privacy, as Onur also mentioned. So what we are developing is also the computing and communication architectures to support this data sharing, to support it in a way that is scalable, because we don't know which application provider, which service provider might have what kind of end-to-end latency requirements, what kind of bandwidth constraints, and so on. So our goal is to create a computing and communication infrastructure that is extremely scalable across different kinds of applications. So the way we are doing it, I'll actually show. So this is a computing and communication infrastructure symbolically, and my colleagues will be elaborating on them. But as Onur pointed out, and he might have used different terminology, but this is, we have heard of mobile computing, mobile edge computing for a long, long time. This is like real mobile computing on the wheels, right? And on the drones, because each of these vehicles and the drones will be carrying a lot of computing with them, and they'll be very mobile. And even the clustering that Onur was talking about, this micro cloud that Onur was talking about, well, this thing is moving, and people are, joining that micro cloud, leaving that micro cloud. So it's a very interesting paradigm, together with the edge computing nodes. And in our case, as I'll explain, the edge computing nodes are all going to be right on the street, RSUs that Onur mentioned, and of course, back up by mobile edge computing node on hopefully AT&T and Verizon and Sprint base stations, and cloud computing, like Amazon kind of cloud computing. So it's a very, very hierarchical as well as very distributed kind of computing. And some of those computing nodes are moving around, right? So it's a very different kind of computing paradigm. And our vision is that we don't want to clog the LTE networks or even the 5G networks. We have gone through these things again and again. That I remember before 3G was coming, and we were developing solutions for streaming video, and a lot of the operators were saying, well, we are going to deploy 3G, we are not going to have any bandwidth issues. And then 3G came, and the bandwidth got clogged. Why? Because YouTube also started coming around. So we see that the communication architecture needs to enable all this data transfer, but in the way as much as possible to not disturb the cellular bands as much as possible. So for that reason, we are also trying out a coordinated effort between unlicensed, sub-6, and millimeter wave. And Onur mentioned also millimeter wave. So you'll see in the demonstration today that in our test bed, we are incorporating all of those bands. And we are not yet there when to move from one to the other, but our goal is to use millimeter wave as much as possible, and then when it becomes challenging, to switch to others. And we'll be hopefully doing that with a lot of machine learning based on trajectories. And I believe that Professor Zhang will be presenting some of that aspect also. Now, this is our vision, and we are doing it in small steps. So our vision is that we don't want to have all this data being shared at as I said, at a cloud level. Our vision is that there'll be RSUs. Each of the RSUs will be a small cell, as nimble as possible, because remember that the cities are not going to pay thousands of dollars to install each of these RSUs. So they have to be very, very low cost. So what we are, and what hopefully we'll be demonstrating today, is very, very mobile, nimble, low cost RSUs, small cell MEC, a mobile edge computing node, all integrated together. And actually what we'll show is implementation on just a Jetson board, everything that is required from baseband processing to EPC to to the machine vision applications, everything in just one small node. So these small nodes will be essentially dividing up the region into these small cell zones, So the streets will be covered in strategic positions by these nodes. And we also want to have these nodes totally renewable energy driven. So we are working with PrimaWind. I don't know whether PrimaWind is in the room today, but to make those base stations totally self-reliant in terms of power needs. And so what we have been doing is installing some of these in our test bed. And we have been instrumenting, as you got to hear from the previous session, the vehicles, the concept vehicles, and we are also bringing in drones, and Marco will be talking about that. And we are now starting to integrate. We have not integrated, but we have started to integrate with our city partners, the smart street IoTs, both in terms of smart lights as well as in terms of smart traffic lights. And we hope to integrate with pedestrians and EV charging stations. I think that many of you are aware that UCSD has been really leading in terms of EV charging stations and grids, and we are slowly going to integrate with those also. With that, I would like to invite Professor Zhang to talk about the testbed in more details, and then the others. One thing I wanted to mention also that when we talk of computing, we are talking of computing in terms of vehicular computing. We call it vehicular edge computing. And this vehicular edge computing, that is offloading the applications to the edge devices, this has to be done also in terms of, well, what are the availability of the edge devices and what are the frequency bands that are operational, right? So one of the talks you'll hear from Professor Kim will be about using millimeter wave and sub-6 together as we offload the vehicular edge computing resources. Thanks.